My name is Kainton the Genius, and today I'm going to show you how to perform multiple linear regression in R. Basically, a data scientist most likely needs to know how to perform multiple linear regression. You might receive a data like this as a data scientist or a data analyst, and you are told to make predictions or make inference. So we have this is an ad campaign or amount spent on radio, TV, and newspaper adverts, and equivalent increase in sales. So can we make sense out of this data? Yes, we can make sense by performing multiple linear regression to see how these ad campaigns on TV, radio and advert affect sales. So for us to continue, we'll use R and we are going to determine the regression coefficients. I'd like to remind you to subscribe to my channel. If you've not subscribed, just click on the subscribe button below to subscribe to my channel. In that way, you don't miss an update when I make new lessons. And also, if you subscribe, you kind of encourage me and motivate me to keep making these lessons. So please click on the subscribe button below to subscribe to my channel. And please leave me a comment if you have any challenges following my lessons. So basically, how much are you going to recommend for them to spend on TV, radio, and adverts to provide or to produce maximum sales? We'll talk about that a little later, but for now, let's do multiple linear regression and determine the regression coefficient and actually find out the equation that relates sales to the ad campaign. So basically, we can say that sales, let's write it using the variables we have. Sales is equal to beta 0 plus, so let's see what we have here. So we have beta 0 plus, so we have TV, beta 1, TV, okay, let me just put in brackets, plus beta 1, this is TV, plus beta 2, our newspaper, okay, I think beta 2 should actually be radio. Beta 2 radio plus beta 3 newspaper. So let's now use R to determine this regression coefficient and actually find this equation. So let's get started. So I'm going to actually use this data exactly. So I'm going to import this data. I have it in my system. If you want, just give me a message that you need this data. I'm going to send it to you. So we have, let's call this data my ads data equals read.csv, and I have it in my drive D. So I'm going to say the \data orders advertising ads .csv. Yes, so this is the data I've imported it. So if I look at ads data, ads data, you can see that we have the data here, but you can see that we have one X column here. Let me teach you how to remove this X here. So we only need TV, radio, newspaper, and sales. So we can just say ads data equals ads data. So you slice off column 1. So we are taking all the rows because there are 200 rows. In case you don't know, let me just show you how to find all the rows and columns. So dying ads data. So you can see there are, oh, what is happening? Ads data. So you can see that there are 200 rows and 5 columns, but we actually need 4 columns. So we are going to take columns 2, 3, 4, and 5. So I'm going to say ads data. I recommend you follow along in your own system. In that way, it's going to be easy for you to understand. So you're going to say ads data equal to ads data. This time we are going to take all the rows 1 to 200. Now we are only going to be taking columns 2, 3, 4, and 5. So you can say columns 2 to 5. So if you now look at ads data again, you'll see that it has a dimension of 200 rows and 4 columns. All right, so let's get to our work to determine the regression coefficient. So what we are going to do is to create a regression model. So to do that, you simply say, I'm going to call it lane mode. Lane mode is equal to the function in R to perform multiple linear regression is the same function to perform linear regression, simple linear regression is LM. So we are going to specify the name of the columns that we want to use. So we are trying to find out how sales is affected by TV, newspaper, and radio. So we can say sales, how it is affected by TV plus newspaper plus radio. All right, so this is what we want to do. We've actually performed multiple linear regression. How do we now get the coefficient of multiple linear regression and then be able to complete our equation? So what we are going to say is summary lane mode. All right, so don't worry, I'm going to explain all of these for you. So here we have estimates, right? So the important thing for us, we have this estimate column. That is what we're interested in. The intercept, which is beta 0, is 2.934. Then the coefficient for TV is 0.004. The coefficient for newspaper is 0.001. The coefficient for radio is 0.189, maybe. All right, so let's now translate this into equation and now see how we can interpret it and see what inference we could make. So first, I'll recommend, let's just write out the coefficients. Let me make some room here. So first we have beta 0 is equal to what? 2.94. Actually, I'll like to use another color of paint. So let me use let me use this color. So we have beta 0 is equal to 2.94. Beta 1 is equal to 0.046. Beta 2 is equal to, which is newspaper, is equal to minus 0.001, and beta 3 is equal to 0.189. All right. Okay. So let's now translate this into this equation and let's see what we have. So we are going to have to be that y. Again, I'm going to change my pen. So let me use a red pen at this time. So let's say y is equal to 2.94 plus 0.046 x1, we'll change it as well, plus, so now I should use minus, so it's going to be minus 0.001 x2, and what is left? Plus 0.189 x3. So writing it in terms of the variables we have in the data set, we can say that sales, let's write in green, meaning that we actually have completed this. So we have sales is related to TV, radio, and newspaper in this way, is equal to 2.94 plus 0.046. Let's just call it newspaper to be, I think we have TV, radio, and newspaper, so we have T. Okay, maybe I'll just write it completely. 0.046 TV plus, so it's actually minus this time, minus 0.001 radio plus 0.0189 newspaper. Okay, so what does it mean? What it means is that sales, 1 unit of sales can be produced by spending 0.046 of TV dollars if we can attach a unit to it, and we decrease the spending in radio by 0.001 and increase spending in newspaper by 0.189. So basically, let's just write it in a different way. We can multiply out by 100, and let's call this a constant. So let's say sales equals, so at this point, I'm going to take out this temporarily. So if we multiply everything by 100, so we have 4.6 TV minus 0.1 radio plus 1.9 newspaper. All right, so actually I multiply by 100, so it can be, so 100 units of sales can be produced if we spend 4.6 dollars on TV and decrease spending on radio by 0.1 and increase spending on newspaper by 1.9. So this is how to perform multiple linear regression in R. I'll try to make it a bit clearer in a different lesson, but for now I'm going to stop here, and I would like to thank you for viewing. And please remember to subscribe to my channel. If you've not subscribed, click on the subscribe button below this video right now to subscribe to my channel. So we'll see you in the next lesson.